Okay, this lecture is over Chapter 9 of your textbook, whose title is Dictionaries and Sets. Before I did Python programming, I did years and years of Perl programming and taught the Perl programming language. And one of my things that I liked most about the Perl programming language was associative arrays. Well, dictionaries are very similar to associative arrays in Perl. So I really like dictionaries a lot. I think they're very, very handy for solving lots of different problems. So in this chapter, we will talk about dictionaries, we will talk about sets, and then we'll talk about reading and writing objects out to a file, which is listed here as serializing objects. So those are the three main topics in this chapter. So we start out with dictionaries, and dictionaries store values. The way they store these values are as key value pairs. So in list you have indexes, and then you have an element of the list that references. With dictionaries, that thing, the key that you would use in place of the index, can be anything. So we have key value pairs. Key is how we identify a specific object, and then the value is the contents of that element within the dictionary. You should think of elements in a dictionary as being unsorted. They could be stored in any order that Python wants to store them. If you want to look at, inspect, or retrieve a value, you put the name of the dictionary, and then just like list in square brackets, you put the key. If you try to print or look up a value for a key that does not exist, the exception that's going to be raised is key error. There are different things you can do. The best and cleanest is to ask if that key is in the dictionary or not in the dictionary, and then do the appropriate thing to avoid getting the exception. If you want to add values to the dictionary, you put dictionary in square brackets, the key, the assignment operator, and then a value. It says dictionaries are mutable objects, which means you can change the value stored at a particular key. So in this statement, if the given key does not exist, it is created in the dictionary and assigned the value you specified. If the key already exists in the dictionary, the value that was there before is replaced with the new value. Sometimes you want to get rid of an entry in a dictionary. You do that with the del keyword. You say del space the dictionary name and the key of the item in the dictionary that you would like to delete. We can use functions that we've seen before on other things, particularly list. For example, there is a length function that will tell you how many key value pairs are in the dictionary. The keys are immutable, but they can point to any type of data. You can have a dictionary that has a key that points to an integer, and another key that points to a float, and another key that points to a string, etc. So you oftentimes are storing the same type of data to solve a problem, but you don't have to. So that's what the last thing is saying. Values stored can be of different types. As far as creating dictionaries, you put values within curly brackets. If you just put open curly bracket, closed curly bracket, that is an empty dictionary. You can also say dictionary name equals DICT, parentheses, which is a call to a function that gives you an empty dictionary. You can iterate over a dictionary. So if you say for something in dictionary, that something is going to be the keys of the dictionary, because that's kind of the most common thing that you would want to look for. The dictionary, or actually a dictionary object, has methods associated with it. The first one they're talking about here is the clear method, which is going to empty out your dictionary. You have a get, so you can call dictionary and get a key, and you can specify a default value that if the key is not found, what it returns. So for example, you could ask for a key in an array of grades and have the default value to be -1. That is some value that would not be in a valid grade. There is an items method that will return the items. That items is a tuple of two values, that is the key and the value. And you can use a for loop to iterate over a dictionary by retrieving the keys and values together. If you want the keys, there is an explicit .keys method that you can use instead of just doing the for loop. So if you don't really want to do a for loop, but you need the keys for some reason, you can call that keys method of the dictionary. A lot of times when you work with a data structure referred to as a stack, you push and pop items onto the stack. So if you pop something, you specify a key and a default, and it will return the value that is at that particular key in the dictionary, but at the same time will remove that key value pair from the dictionary. And just like before, we can specify a default value to be returned if the key value pair does not exist in the dictionary. Pipe item is returns a tuple. It's the key value pair that was last added to the dictionary, and it also removes that key value pair. I find this a little strange because, you know, it tells you that dictionaries are unordered, but yet it has the concept of the last thing that was added. So somehow Python is keeping track of the order items were added to a dictionary. Just like there's a keys method, there's a values. So if you just need to retrieve the values function, you can do that. You can use that in a for loop, of course, any list, to iterate over the values that you got from the dictionary. You know, maybe you're calculating an average or a minimum or something like that. Here's some functions. It looks like all the ones that are in this table we have just finished talking about. So the next topic that we talk about in this chapter is merging things, or the merge operator. And for dictionaries, the merge operator is what people would call the vertical bar or the pipe symbol. If you say dictionary 1, pipe dictionary 2, it is going to combine those two into a new dictionary, and in this case we'll store that new dictionary in dictionary 3. Now then, the one thing that I don't know that we were super clear about, it was at least implied, is that you can have two key value pairs that have the same key. That just would not make sense. So if you have the same key in Dictionary 1 and Dictionary 2 in this example, it's going to keep the value that was in Dictionary 2 because it was on the right hand side of the merge operator. You can update dictionaries with the pipe equal symbol or operator. What this does is it works like the merge operator, but it is going to put that merging into the dictionary. So this is really just an augmented operator, which is equivalent to Dictionary 1 equal Dictionary 1 vertical bar Dictionary 2. We have comprehensions, which again are expressions for iterating over something, in this case a dictionary. So here we have examples where we go through and we set up some numbers, and then we go through and for each of those calculate a square. So those are, we have keys, and the resulting value is going to be the square of the key. So down here we created an array, and you'll see that at key 1 it has the value 1, at key 2 it has the value 4, etc., which are the square of the keys. Here is a comprehension to accomplish the same thing. So basically we took 4 lines of code and simplified it down to 1 line of code, and as you will see in idle, they are printing out, or in the Python interactive interface, they are printing out squares, which happens to be a dictionary, and it is showing you all the key value pairs in the dictionary. So here they're just talking about what that expression does. This one's fairly straightforward. Here what we're doing is we're taking a list of names, and we're wanting to create a dictionary that as the key has the name, and as the value at that key has the number of characters that are in that name. So for each of the items, we are calculating the string length and putting it into the dictionary. Here they're showing us how to make a copy of a dictionary. So basically for every key value pair in Dictionary 1 that we get with the items method stored in Dictionary 2, and you'll see that we say Dictionary 2, which is just going to show you the contents of that variable, which in fact is a exact copy of Dictionary 1. You can use an if clause to select only certain items. So here we have a comprehension that is wanting to get the key value pairs for cities that have a population greater than 2 million. And out of that list, that would be New York, Los Angeles, and Chicago and Houston. So that's dictionaries and some of the things you can do to dictionaries. We're going to move on now to sets. Sets is a collection of data, and this is really like from set theory in mathematics. A set is unordered, just like a dictionary is unordered, and the data in it can also be of different types. So it's kind of like a dictionary, but there's no keys. There is a set function. If you call it with no arguments, you're going to get an empty set. You can call the set function with an argument, and that argument can be a list, a string, a variable, a tuple. If the weird thing is, if the argument is a string, then each character becomes a member of the set, which may or may not be what you want or what you would think would happen. A set has to be unique, so if you pass duplicate items in in the argument list, it is going to only put one occurrence of that in the set. Just like a lot of things that have multiple items, you can call the length function and it will return how many elements in the set. Sets are mutable, which of course means they can be changed. There is an add method to add a single element to a set. However, there's an update method which will allow you to add a group of elements. So if you call the update method, what they're saying here is it has to be something that is iterable, like a list, and each of the items will be added to the set. There is a remove and discard that remove a specified item from the set. The difference is if you discard something and it's not in the set, it just does nothing. However, if you remove or call the remove method to try to remove something from the set and that element is not in the set, then you're going to get a key error. So, you might want to know if it doesn't exist and get the exception, but a lot of times you're just going to call the discard method and say, well, if it's there, get rid of it. If it's not there, no big deal. We wanted it to be gone anyway. Sets have a clear method, which remove all the items from a set. You can iterate over a set. So if you have a for loop, you will get every occurrence of items within the set. Again, you should assume in no particular order. You can use the in and not in operators to test for existence or non-existence of a value in a set. In mathematics, when you're dealing with sets, one of the things you do is find a union. A union of a set is where you draw in math two circles that overlap, and the things in the overlap are the union of the sets. And what that means is it is the elements or items in the set that are in both the first and second set you're referring to. To find the union of two sets, you use the union method from one set, and then you can say put the other set inside there and it would return the union. Or you can use the vertical bar, which will find the union of the two sets. In both cases, regardless of how you calculate that union, it is going to return a new set, which is indeed the union of the two specified sets. Okay, going to have to back up. So here we're talking about getting the union of two sets. A union is adding two sets together and creating a new set that has all the elements that are in both sets. There's a couple ways to do that. We can use the union method of one of the sets and as an argument pass the second set, and it will add the two lists together. Or you can use the pipe symbol to say set 1 pipe set 2, and both of these methods or techniques will return a new set that contains all the items from set 1 and set 2. Now then, to find the intersection of a set, this is items or elements that can only be found in both sets. We can either use the intersection method or we can use the ampersand operator, which is the intersection operator. In this case, we will get a new set, and that new set will only contain the elements that are in both of the specified list. Finding the difference, this is basically find all the elements that are in the first set that do not appear in the second set. And the way we can do that is we can either use the difference method or we can use the minus operator. So those are two ways to find the intersection. Symmetry of two sets is one thing that at least I didn't deal with whenever I was learning set theory. But a symmetric difference is a set that contains elements that are not shared by the two sets. So we can either do that with the symmetric difference method or by putting the caret operator, which is a shifted 6. Another thing that you sometimes want to do with sets is to ask if something is a subset or a superset. So A is a subset of B if all the elements are included in set B. B may have additional items, but the main thing is everything that's in set 1 is also in set B. To find out if set A is a subset of B, we can call the isSubset method on, in this case, set A, and then pass set B in, or we can use the less than equal symbol to do the exact same thing. Superset means it includes all the elements in set B plus possibly more. So we can use isSuperset or the greater than or equal symbol, since subset and superset are kind of implying less than an equal or greater than an equal. So we use the same operators that we would use for numeric values. But Python's smart enough to know, hey, this is a set, so I'm actually doing superset or subset. We can have comprehensions for iterating over sequences. So we can use these with sets. The only difference is we include these in curly brackets. So we, in that first line of code, create a set that has 5 elements. We then iterate over those 5 elements and store them in set 2. And if we ask Python to show us the contents of set 2, then it will say this is a set and here are the values of the set. Here we're going through and taking set 1 and squaring or raising to the second power all the values in set 1 and sticking them in set 2. After that comprehension executes, we can ask to see the contents of set 2, and it shows us that set that has 5 items in it. Here we have a set, and what we care about is iterating over that set and getting all the values for some reason that are less than 10. And after that comprehension executes, we say show me the contents of set 2 to indeed show you that it does have 1, 2, 3 in it, but does not include 20, 40, and 50 because all those values are greater than 10. So that finishes up the discussion of sets. Our last topic is serialization of objects. And basically what that's doing is converting an object to a string of bytes that can be stored in a file. And this is called pickling in Python. So if you say you pickle an object, that means you write it out to a file. The purpose being so you can retrieve it later and reinstantiate or recreate whatever that object was. There is a pickle module that reads and writes files. This serialization works with binary data. So if you call it opens or you need to open the file for binary write, which we'll see how to do that in a moment, and then you call the pickle.dump function, and what you do is you specify the object that you want to serialize, and then the file handle or the file object for whatever file you want to write it to. And then, as always, when you're done dealing with a file, you should close it. You can write out or pickle multiple objects to a file before closing the file if you need to do that. Here's an example. We have a phone book that has 3 names and 3 phone numbers. We can open the file phonebook.dat and WB, and this may be the first time we've seen this. You're opening it for write, that's what the W means. And if you just use W, it opens it as a text file. But if you add that B, it opens it for binary write. And then you call pickle.dump on your phone book dictionary, and then you specify the output file that you would like to write to. To unpickle or retrieve the items, again, you have to import the pickle module, and then you do a pickle.load, and you specify the file, and you can either unpickle one item or multiple items from the file, depending on what you wrote out. And here's an example. We want to read the file. Again, we need to specify that it is a binary file, and then we say PB, our abbreviation for phone book, equals pickle.load, and then we print out PB, and you will see that we have a dictionary that has 3 people, their name being the key and their phone number being the value. So that covers the 3 topics in Chapter 9, which was primarily dictionaries, sets, and serializing objects. So there's part of the things we talked about, and then here are the rest of the things that we talked about. So that finishes up our lecture on Chapter 9 of your textbook.